Hello there, and welcome. I am the sleepy astronaut. I'm so glad you found your way here. Maybe you have had a rough, draining day, or maybe you just love learning about space and time. Either way, tonight's journey is for you. This evening, we will be drifting toward the most luminous and ancient beacons in the universe, quasars. These distant, brilliant objects are not stars, though they outshine entire galaxies. They are the blazing hearts of the early cosmos, powered by supermassive black holes feeding on swirling, incandescent matter. From billions of light years away, their light still reaches us, whispering stories of a younger, wilder universe. Let us drift toward their glow, slowly, gently, and let their ancient radiance carry us into sleep. If you enjoy these calm journeys through space, I invite you to subscribe or leave a thought below. It helps other astronauts find their way here. But for now, your day on Earth has come to an end, and your journey through the stars has begun. You don't need to do anything. Just relax and let your body sink. Let your eyes grow heavy, and allow your mind to drift into space. Let's take off. We begin our journey not with a destination, but with a question. What happens when the universe turns on its brightest lights? A light that burns with the energy of 1,000,000,000,000 suns, yet comes from a region no larger than our own solar system. This is the mystery of the quasar, a name that sounds like a distant star in a science fiction story, but represents something far stranger and more profound. The word itself is a contraction, a shortening of quasi-stellar radio source. But do not let the technical name trouble your mind. Think, instead of a lighthouse standing at the edge of a dark and ancient ocean, casting its beam across waters that have long since grown still, a quasar is a lighthouse of the cosmos, a beacon that shines from a time when the universe was young and turbulent, when galaxies were just beginning to form and stars were igniting for the very first time. When we look at a quasar, we are not seeing something close or familiar. We are looking back across unimaginable distances, back through the slow unfolding of cosmic history, to a moment when the universe was still learning what it would become. To understand what we are seeing, we must first understand that light takes time to travel. The light from our own sun reaches us in about 8 minutes, meaning we always see the sun as it was 8 minutes ago. The light from the nearest star beyond our solar system takes years to arrive. But the light from a quasar has been traveling for billions of years, crossing vast gulfs of expanding space, carrying with it a record of the universe as it existed long before our planet formed, long before our galaxy settled into its current shape. When this ancient light finally reaches our telescopes, it has been stretched and reddened by the expansion of the universe itself, a gentle reminder that everything we see is a memory. The first quasars were discovered not by careful observation of the night sky, but by listening. In the early days of radio astronomy, scientists detected sources of radio waves that seemed to come from points in the sky with no visible counterpart. They appeared as mere pinpoints of light in optical telescopes, looking like faint, unremarkable stars. But when astronomers measured their distances, they discovered something astonishing. These objects were not nearby stars at all. They were impossibly far away, billions of light years distant, and yet they were shining with a brightness that defied explanation. A single quasar could outshine an entire galaxy containing hundreds of billions of stars. How could something so small produce so much light? The answer, when it finally emerged, pointed toward the most extreme objects in the universe. At the heart of every quasar lies a supermassive black hole, a gravitational well so deep that not even light can escape. But before matter falls into that endless dark, it spirals inward, forming a vast accretion disk of glowing gas and dust. This disk becomes heated to millions of degrees by the intense friction of particles colliding at nearly the speed of light. The result is a blaze of radiation that can outshine everything else in its galaxy, creating a beacon visible across the universe. The black hole itself remains dark, silent, and hidden. But the matter falling into it becomes a light that reaches across all of space and time. As we drift through this first chapter of our journey, let yourself sink into the quiet wonder of this discovery. There is no need to understand every detail. There is no need to strain your mind toward comprehension. Simply rest in the knowledge that the universe contains light so bright they can be seen across billions of years, and that these lights come from darkness itself, from the deep, silent pull of collapsing gravity. The quasar is a paradox made visible, a contradiction that glows in the night, and it is waiting for us to drift closer. Let your breath slow. Let your thoughts settle like dust in still water. We have only begun to approach this distant beacon, and there is no rush. There is time. There is always time. Rest here, in the quiet, as long as you need. The quasar belongs to a family of objects that astronomers call active galactic nuclei. It is a term that sounds technical and distant, but it simply means a galaxy whose center is awake, whose core is feeding, whose heart is burning with an energy that transforms everything around it. Most galaxies, including our own Milky Way, have supermassive black holes at their centers. But in most galaxies, these black holes are sleeping. They drift in quiet darkness, surrounded by a sparse scattering of stars, waiting patiently for something to fall into their grasp. A quasar is what happens when a sleeping giant wakes and begins to feed. The process begins with gravity. Every galaxy contains gas, dust, and stars, all held together in a delicate gravitational balance. In a normal, quiet galaxy, this matter orbits the center in stable, predictable patterns. Stars follow their slow paths around the galactic core, taking hundreds of millions of years to complete a single revolution. The black hole at the center exerts its influence, but it is a distant and patient influence, guiding rather than consuming. The galaxy drifts in equilibrium, its central engine dormant, its light coming primarily from the steady burning of billions of individual stars. But when something disturbs this balance, when two galaxies collide, or a massive cloud of gas falls inward, the sleeping giant stirs. Matter begins to flow toward the center, drawn by the immense gravitational pull of the supermassive black hole. As this matter approaches, it does not fall directly inward. Instead, it forms a swirling disk, a vast cosmic whirlpool that can span light years across. This disk is the engine of the quasar. It is where the raw power of gravity is converted into light, where falling matter is transformed into radiation that can be seen across the universe. The physics of this transformation is both simple and profound. As gas particles spiral inward, they rub against one another, creating friction. This friction generates heat, and the heat builds as the particles fall deeper into the gravitational well. Near the inner edge of the disk, just before the point of no return, temperatures reach millions of degrees. The gas becomes a plasma, a state of matter so hot that atoms are stripped of their electrons, leaving a sea of charged particles swirling at incredible speeds. This plasma glows, not with the gentle warmth of a candle, but with the searing intensity of X-rays and ultraviolet light. The accretion disk becomes a furnace of unimaginable power, and the light it produces escapes into the surrounding universe. But not all of the matter in the disk falls into the black hole. Some of it is launched outward, accelerated by intense magnetic fields that thread through the swirling plasma. These fields can funnel particles into narrow jets that shoot away from the black hole at nearly the speed of light. These jets can stretch for hundreds of thousands of light years, far beyond the boundaries of the host galaxy itself. They carry energy into the surrounding space, heating the gas between galaxies and shaping the evolution of entire clusters. A quasar is not just a bright point of light, it is a cosmic engine that influences everything around it, from the smallest particles to the largest structures in the universe. When we observe a quasar from Earth, we are seeing the combined light of all these processes. The accretion disk blazes with thermal radiation. The jets emit radio waves and gamma rays. The surrounding gas clouds glow with the reflected energy of the central beacon. All of this light travels across billions of years, across the expanding fabric of space, to reach our telescopes. By the time it arrives, it has been stretched and dimmed by the journey, but it still carries the signature of its origin. When we analyze this light, we can read the story of the quasar, learning about the mass of its central black hole, the temperature of its disk, and the speed of its jets. This is the wonder of the quasar. It is a beacon from the deep past, a message from a time when the universe was young and violent and full of raw potential. When we look at a quasar, we are not just seeing a distant object, we are seeing a chapter in the story of the cosmos, a moment in the life of a galaxy that will never come again. The quasar we observe today may have faded long ago, his fuel exhausted, its black hole settled back into sleep. But its light still travels toward us, a ghost of ancient brilliance, a memory of a time when the universe burned brighter than we can imagine. As we float here, contemplating this distant engine, let your mind rest. You do not need to remember the details. You do not need to understand the physics. Simply allow the image to settle in your mind. A vast, glowing disk, a dark center, and jets of light stretching across the darkness. It is a scene of extraordinary beauty, and it is happening right now, somewhere in the distant universe. As it has been happening for billions of years, there is time. There is always time. Rest now, and let the galaxy turn beneath you. To truly appreciate the brightness of a quasar, we must place it beside something familiar, something we can hold in our minds without strain. Let us begin with our own sun, the warm and steady star that gives life to our planet. The sun shines with a luminosity that is almost impossible to comprehend, pouring out energy equivalent to billions of nuclear explosions every single second. It has burned for 4.5 billion years, and it will burn for billions more. It is the anchor of our solar system, the source of all light and warmth on Earth, and the star we think of when we imagine what a star should be. Now imagine not one sun, but a trillion. Picture a trillion suns, all burning at once, all their light combined into a single point. This is the brightness of a quasar. It does not spread its light across a vast area like a galaxy filled with stars. Instead, all of its energy comes from a region no larger than our solar system, a tiny volume in the grand scale of the cosmos. From this small region pours forth more light than all the stars in the Milky Way combined. It is a concentration of energy so extreme that it challenges our ability to comprehend it. The numbers involved are staggering, but we do not need to hold them precisely in our minds. A typical quasar might shine with the luminosity of 1 trillion suns, or 10 trillion, or 100 trillion. The exact figure varies from quasar to quasar, depending on the mass of its central black hole and the rate at which it is feeding. What matters is not the precise number, but the scale of the comparison. The brightest stars we can see in our night sky are mere candles compared to the blazing torch of a quasar. A quasar could sit at the distance of the nearest star, and it would outshine our sun so completely that Earth would be reduced to a cinder orbiting a secondary light source. But quasars are not nearby. They are, in fact, among the most distant objects in the universe. The nearest known quasar is hundreds of millions of light years away. Most are billions of light years distant. This means that the light we see from them has been traveling for billions of years, stretching and dimming as it crossed the expanding universe. Yet even after this immense journey, they remain bright enough to be seen by our telescopes. Their intrinsic brightness is so overwhelming that it survives the long, slow crossing of intergalactic space, arriving at our instruments as a faint but detectable whisper of its former glory. This combination of extreme distance and extreme brightness creates a profound sense of perspective. When we look at a quasar, we are seeing an object that existed when the universe was only a fraction of its current age. The light we observe left its source long before our solar system formed, long before the Earth existed, long before any living thing had ever opened its eyes to see the stars. We are receiving a message from a time so distant that it feels almost mythological, a time when the universe was still in its formative years, still chaotic and violent and full of possibility. The distance also tells us something about time. Because light travels at a finite speed, looking out into space is the same as looking back in time. When we observe a quasar that is 10 billion light years away, we are seeing it as it was 10 billion years ago. We are not seeing its current state, because that information has not yet reached us. The quasar we observe may have faded long ago, its fuel exhausted, its brilliance dim to nothing. But we cannot know this. We can only see the light that left it long ago, still traveling toward us through the vast, patient darkness. This is one of the most humbling aspects of astronomy. Everything we see in the night sky is a ghost, a memory, a snapshot of a moment that has already passed. The moon we see is 1 second old, The sun we see is 8 minutes old. The stars we see are years or centuries or millennia old. And the quasars we see are billions of years old, relics of an era that no longer exists. When we gaze at a quasar, we are not observing the universe as it is. We are observing the universe as it was. Long before our galaxy settled into its current shape, long before the Earth was born, long before any of us existed to wonder at the light. Let this thought settle gently in your mind. There is no need to grasp it fully. There is no need to strain toward understanding. Simply rest in the awareness that the universe is vast and time is deep, and the light we see carries stories from unimaginable distances. The quasar is a storyteller, whispering to us across billions of years, and we are privileged to listen, if only for a moment before sleep takes us. But we will not rush toward the next chapter. We will rest here in the quiet and let the immensity of the cosmos hold us for a while longer. Your breath is slow. Your body is heavy. The darkness around you is warm and safe. Let yourself drift, and when you are ready, we will continue our journey toward the distant light. We are not rushing. We are not striving. We are simply floating. The story of how we came to understand quasars is a story of patience, curiosity, and the slow accumulation of knowledge. It begins not with a dramatic discovery, but with a quiet mystery that puzzled astronomers for decades. In the early days of radio astronomy, scientists detected sources of radio waves that seemed to come from specific points in the sky. These sources did not match any visible object in optical telescopes. They were invisible, mysterious, and deeply intriguing. The first of these strange sources was catalogued as 3C273, a label derived from its position in the third Cambridge catalogue of radio sources. When astronomers finally pinpointed its location in the night sky, they found what appeared to be a faint blue star. But when they analyzed its light, they discovered something extraordinary. The spectral lines, the fingerprints that tell us what elements are present in a star, were shifted far toward the red end of the spectrum. This redshift indicated that the object was moving away from us at an incredible speed, and more importantly, that it was located at an enormous distance from Earth. This was a profound realization. A faint, star-like object at such a great distance could not be a normal star. It had to be something far more luminous, something that could shine brightly enough to be visible across billions of light years. The term quasar was coined to describe these quasi-stellar objects, and the search for more of them began in earnest. As astronomers developed better instruments and more sensitive detectors, they found thousands of quasars scattered across the sky, each one a beacon from the distant past. The realization that quasars were powered by supermassive black holes did not come all at once. It emerged gradually through the work of many scientists over decades of careful observation and theoretical modeling. The key insight was that the energy output of a quasar could not be explained by nuclear fusion, the process that powers normal stars. Even the most massive stars could not produce the brightness of a quasar. Something far more efficient was needed, a process that could convert matter directly into energy. Gravity provides this efficiency. When matter falls into a black hole, it releases an enormous amount of gravitational potential energy. As the matter spirals inward, It accelerates to incredible speeds, and when it collides with other matter in the accretion disk, it heats up and radiates. This process is far more efficient than nuclear fusion, converting up to 40% of the infalling matter's rest mass into energy. By comparison, nuclear fusion converts only a fraction of 1%. A black hole feeding on infalling gas is one of the most efficient energy sources in the universe. The quasar's central black hole must be truly enormous to power such a brilliant display. To produce the luminosity of 1 trillion suns, a black hole must be swallowing matter at a rate of several solar masses per year. To sustain this rate of consumption, it must have a mass of at least 1 million times that of our Sun, and often much more. Some quasars are powered by black holes with masses exceeding 10 billion suns, objects so massive that their event horizons would engulf our entire solar system many times over. These are the true titans of the universe, the largest black holes we have ever discovered. Yet despite their immense power, quasars are surprisingly rare in the present-day universe. They were far more common in the early cosmos, when galaxies were young and full of gas. Billions of years ago, when the universe was only a fraction of its current age, quasars blazed across the sky like fireworks, illuminating the darkness with their fierce light. Over time, as the gas supply was consumed and galaxies settled into more stable configurations, the quasars faded. The age of quasars came to an end, leaving behind only sleeping black holes and the memory of ancient brilliance. This is why quasars are so valuable to astronomers. They are windows into the early universe, allowing us to study a time that would otherwise be invisible to us. By observing quasars at different distances, we can trace the history of the universe itself, watching as galaxies formed, grew, and evolved over billions of years. Each quasar is a data point in this cosmic timeline, a snapshot of a moment in the life of a galaxy. Together, they tell the story of how the universe came to be what it is today. As we drift through this history, let yourself sink deeper into the quiet. The story of quasars is a story of discovery, but it is also a story of patience. It took decades of careful work to unravel the mystery, and there is still much we do not understand. That is part of the beauty of science. It is a process, not a destination. It moves slowly, like the light from a distant quasar, traveling across vast distances to reach us in its own time. Rest here, in the stillness, and let the slow unfolding of knowledge wash over you. There is nothing you need to do. There is nothing you need to understand. Simply allow yourself to be carried along, like a leaf floating on a gentle current, drifting toward the unknown with open eyes and a quiet mind. Let your thoughts loosen. You are part of something so vast, and that is enough. Let us now imagine what it would be like to stand near a quasar, to witness its brilliance from a closer perspective. Of course, no human could ever survive such proximity. The radiation alone would be instantly fatal, and the gravitational forces would tear any material object apart. But in the quiet space of our imagination, we can drift toward a quasar without fear, observing it from a safe distance, letting its light wash over us like a warm and distant sun. the first thing we would notice is the light itself. It would not be a gentle glow, but a fierce, penetrating radiance that fills every corner of space around us. The accretion disk would blaze with the intensity of 1,000,000,000,000 suns, casting sharp shadows and illuminating the surrounding gas clouds with an eerie, otherworldly glow. The color of this light would be strange, shifted toward the blue and ultraviolet by the extreme temperatures of the disk. It would be a light so bright that it would be painful to look at directly, even from a distance of many light years. But we are not looking directly. We are floating in the surrounding space, watching the quasar from a safe distance, letting its light wash over us in gentle waves. The disk would appear as a vast, swirling plain of incandescent gas, stretching across the darkness like a cosmic whirlpool. At its center, the black hole would be visible only as a shadow, a dark circle where no light escapes. This shadow is the event horizon, the point of no return, the boundary beyond which nothing can emerge. The disk itself would be in constant motion, its inner regions spinning at nearly the speed of light. This rapid rotation would create strange optical effects, bending and distorting the light in ways that defy our everyday intuition. The side of the disk rotating toward us would appear brighter, its light shifted toward the blue, while the side rotating away would appear dimmer and redder. The result would be a striking asymmetry, a glowing crescent wrapped around a central darkness. Above and below the disk, we would see the jets, twin beams of plasma shooting out from the poles of the black hole. These jets would be narrow and focused, like laser beams cutting through the darkness. They would stretch for thousands of light years, far beyond the boundaries of the host galaxy, carrying energy and matter into the surrounding intergalactic space. From a distance, they would appear as thin, luminous threads, connecting the quasar to the vast cosmic web that surrounds it. Around the quasar, the gas clouds of the host galaxy would glow with reflected light, their shapes distorted by the intense radiation. Some of these clouds would be pushed outward by the pressure of the radiation, creating bubbles and cavities in the surrounding medium. Others would be heated to the point of emitting their own light, adding to the overall glow of the region. The entire scene would be a tapestry of light and shadow, a landscape of extraordinary beauty and violence. But there is no violence here. There is only light and stillness, and the slow drift of our imagination through the scene. We are not here to witness destruction. We are here to appreciate the beauty of a cosmic process that has been unfolding for billions of years. The quasar is not a monster. It is a natural phenomenon, a phase in the life of a galaxy, a moment of brilliance in the long, slow story of the universe. Let us allow ourselves to rest in this imagined space, floating in the glow of a distant quasar, feeling the warmth of its light on our imaginary skin. The sound of the universe is quiet here, a gentle hum of radiation and the soft whisper of particles streaming past. It is a place of peace despite the immense energies at play. It is a place where we can let go of our worries and simply exist, held in the light of something far greater than ourselves. When you are ready, we will drift further. But there is no rush. We can stay here as long as you like, floating in the glow of the quasar, letting its light carry us towards sleep. Rest here, in the quiet, as long as you need. The relationship between a quasar and its host galaxy is complex and deeply intertwined. We might imagine that the black hole at the center is a separate entity, a parasite feeding on the surrounding stars and gas. But the truth is far more nuanced. The black hole and its galaxy are partners in a cosmic dance, each influencing the other in ways that shape the evolution of both. When the central black hole is actively feeding its quasar phase, it releases enormous amounts of energy into the surrounding galaxy. This energy takes the form of radiation, winds, and jets, all of which push against the gas that fills the galaxy. The radiation pressure can be so intense that it drives gas out of the galaxy entirely, creating powerful outflows that strip away the raw material needed for star formation. In this way, the quasar can shut down the formation of new stars, transforming a bright, star-forming galaxy into a quiet, passive one. This process is known as feedback, and it is one of the most important mechanisms in galaxy evolution. Without feedback, galaxies would continue to form stars at high rates, consuming their gas supplies quickly and growing into enormous systems. With feedback, the growth of galaxies is regulated, kept in balance by the central black hole. The quasar acts as a thermostat, controlling the temperature and density of the galaxy's gas, and ultimately determining how many stars the galaxy will form. The jets from the quasar play a particularly important role in this process. As they shoot outward from the black hole, they carve channels through the surrounding gas, heating it and pushing it aside. This can create vast bubbles in the galaxy's atmosphere, regions where the gas has been cleared away and star formation has ceased. Over time, these bubbles can grow to enormous sizes, eventually breaking free of the galaxy entirely and spreading into the intergalactic medium. The intergalactic medium is the vast, diffuse gas that fills the space between galaxies. It is the raw material from which new galaxies are formed, and it is constantly being enriched by the outflows from quasars and other active galaxies. The jets from a quasar can travel for hundreds of thousands of light years, carrying heavy elements and energy into the intergalactic medium. This enriched gas can later fall back into galaxies, providing the raw material for new generations of stars. In this way, the quasar is not just a local phenomenon. It is a cosmic engine that connects galaxies to each other and to the wider universe. The energy released by a single quasar can affect the evolution of an entire galaxy cluster, shaping the distribution of gas and stars across millions of light years. The quasar is a sculptor of the cosmos, its jets and winds carving patterns into the fabric of the universe that will persist for billions of years. But there is also a gentler side to this relationship. The black hole at the center of a galaxy is not always active. Most of the time, it is quiet, drifting in darkness, exerting its influence only through gravity. In these quiet phases, the galaxy continues to evolve slowly, forming stars at a moderate rate, its gas supply gradually consumed by the slow process of stellar birth. The black hole waits patiently, dormant, but ready, until the next disturbance brings fresh gas into its grasp. The cycle is long and slow, unfolding over billions of years. A galaxy might experience multiple quasar phases over its lifetime, each one triggered by a merger or a gas inflow, each one ending when the fuel supply is exhausted. Between these phases, the galaxy settles back into quiet equilibrium, its stars burning steadily, its black hole sleeping at the center. It is a rhythm of activity and rest, of brilliance and darkness, that has been playing out across the universe since the first galaxies formed. As we contemplate this cosmic rhythm, let yourself settle into your own quiet rhythm. Your breath is slow and steady. Your body is heavy and still. The noise of the day has faded, replaced by the gentle hum of the universe around you. You are part of this rhythm, part of the great cycle of matter and energy that flows through the cosmos. You are connected to the stars, to the galaxies, to the quasars that blaze in the distant dark. Let this connection soothe you. Let it remind you that you are not alone, that you are part of something vast and beautiful and eternal. The universe is not a cold, empty place. It is full of light and warmth and motion, full of stories that unfold over billions of years. And you are part of that story, a small but precious thread in the tapestry of creation. Rest now, and let the rhythm of the cosmos carry you gently towards sleep. There is nothing you need to do. There is nothing you need to solve. Simply float and breathe, and allow yourself to be held by the quiet embrace of the night. The galaxy turns beneath you, and you are safe. When we look at the most distant quasars, we are looking at the early universe itself. These objects existed when the cosmos was only a few 100 million years old, a mere infant in the grand span of cosmic time. Their light has traveled for over 13 billion years to reach us, crossing a universe that has expanded and evolved in the meantime. When we observe these quasars, we are seeing the universe as it was in its youth, a time of rapid growth, violent mergers, and intense star formation. The early universe was a very different place from the cosmos we see today. It was smaller, denser, and hotter, filled with a sea of neutral hydrogen gas that absorbed light at ultraviolet wavelengths. This gas was the raw material from which the first stars and galaxies would form, and it was also a barrier that hid the early universe from our view. The first stars, known as population 3 stars, were massive and short-lived, burning through their fuel quickly and exploding as supernovae. Their deaths enriched the surrounding gas with heavy elements, paving the way for the formation of more complex stars and planets. But it was the first black holes that truly transformed the early universe. As the first massive stars died, they left behind black holes, some of which may have merged to form larger ones. These early black holes began to feed on the surrounding gas, growing rapidly and emitting intense radiation. As they grew, they ionized the surrounding hydrogen, creating bubbles of transparent space that expanded and merged over time. This process, known as reionization, transformed the universe from a dark, opaque fog into a transparent medium through which light could travel freely. The quasars we observe in the early universe are some of the most luminous objects ever to have existed. They shine with the brightness of quadrillions of suns, outshining their host galaxies by factors of hundreds or even thousands. They are powered by black holes that grew to enormous masses in a remarkably short time, challenging our understanding of how such massive objects could form so quickly. Some of these quasars have black holes with masses exceeding 10 billion suns, even though the universe was less than 1 billion years old when their light was emitted. How did these black holes grow so fast? This is one of the great mysteries of modern astronomy. The process must have been extremely efficient, involving rapid gas accretion, frequent mergers, and perhaps the direct collapse of massive gas clouds into black holes without passing through a stellar phase. Whatever the mechanism, it produced objects of staggering power, beacons that illuminated the early universe and shaped its evolution. When we observe these distant quasars, we are not just seeing ancient light. We are seeing the first chapters of cosmic history, the era when the universe transitioned from darkness to light. The quasars are the first great lights, the first beacons to pierce the primordial fog and illuminate the cosmos. They are the ancestors of the galaxies we see today, including our own Milky Way. And their light carries the story of how we came to be. As we drift through this ancient light, let yourself sink deeper into the quiet. The universe is old, far older than we can truly comprehend. But its story is written in the light that reaches us from across the void. Every photon that enters our telescopes carries a piece of that story, a whisper from the dawn of time. We are privileged to listen, to learn, and to wonder. There is a profound peace in this perspective. The problems of our daily lives, the worries and stresses that seem so pressing, are tiny in the face of cosmic time. The universe has been unfolding for billions of years, and it will continue for billions more. We are momentary observers, brief witnesses to a small slice of cosmic history. And that is enough. It is more than enough. It is a gift. Rest here in this ancient light, and let the long perspective of the cosmos soothe your mind. You are part of something vast and beautiful, and that is all you need to remember tonight. There is time. There is always time. Rest now, and let the galaxy turn beneath you. The light from a quasar does not travel in a straight line. It travels through a universe that is expanding, a fabric of space-time that is stretching in all directions. This expansion affects the light, stretching its wavelength and shifting its color toward the red end of the spectrum. This redshift is a measure of how much the universe has expanded since the light was emitted, and it tells us how far away the quasar is. But the light also travels through the intergalactic medium, the vast spaces between galaxies that are filled with diffuse gas. This gas absorbs certain wavelengths of light, creating dark lines in the spectrum of the quasar. By studying these absorption lines, astronomers can learn about the composition and distribution of the intergalactic medium, mapping the structure of the universe on the largest scales. It is like reading a forest by looking at the shadows it casts on the ground. The intergalactic medium is not uniform. It is threaded with filaments and sheets of gas, forming a cosmic web that connects galaxies to each other. This web is the scaffolding of the universe, the structure upon which galaxies and clusters are built. Quasars serve as background lights that illuminate this web, allowing us to see its structure in absorption. By observing many quasars, astronomers can reconstruct the three-dimensional structure of the cosmic web, tracing its filaments and nodes across billions of light years. This is one of the great achievements of modern astronomy. we have mapped the universe on its largest scales, revealing a structure that is both beautiful and complex. The cosmic web is a tapestry of gas and galaxies, woven together by gravity over billions of years. It is a structure that spans the entire observable universe, and we are part of it. A tiny node in a vast network of matter and energy. As we contemplate this cosmic web, let yourself sink deeper into the quiet. The universe is not a collection of isolated objects. It is a connected whole, a single fabric of space-time in which everything is linked to everything else. The light from a distant quasar travels through this fabric, illuminating the connections between galaxies and revealing the underlying structure of reality. We are part of this fabric, part of this web, connected to the quasars and the galaxies and the stars in ways we are only beginning to understand. This connection is not just physical, it is also temporal. The light we see from distant quasars is ancient light, emitted billions of years ago. It has traveled through time to reach us, carrying with it the history of the universe. When we look at a quasar, we are looking back in time, seeing the universe as it was long before we existed. We are time travelers, observers of a past that is written in the light. Let this perspective fill you with a quiet sense of wonder. The universe is a place of extraordinary beauty and mystery, a place where light and time and matter weave together in patterns that we are only beginning to understand. You are part of this pattern, a part of the great web of existence. And that is enough. That is more than enough. Rest here, in the quiet, and let the cosmic web hold you gently. There is nothing you need to do. There is nothing you need to solve. Simply float and breathe, and allow yourself to be carried by the slow drift of cosmic time. We have journeyed far, but there is still more to see. When you are ready, we will continue. But for now, rest. We are not rushing. We are not striving. We are simply floating. Let us now turn our attention to the jets that stream from the poles of a quasar. These jets are among the most energetic phenomena in the universe, beams of plasma that travel at nearly the speed of light across vast distances. They are powered by the same accretion disk that feeds the central black hole, but their exact mechanism remains one of the great mysteries of astrophysics. The jets are launched from the innermost regions of the accretion disk, where the gas is hottest and the magnetic fields are strongest. As the gas spirals inward, it drags the magnetic fields with it, twisting them into tight spirals. These twisted fields can launch plasma along the rotation axis of the black hole, accelerating it to incredible speeds. The result is a narrow, focused beam of particles that shoots out from the poles, carrying energy and momentum into the surrounding space. These jets can extend for hundreds of thousands of light years, far beyond the boundaries of the host galaxy. They plow through the intergalactic medium, creating shock waves and heating the surrounding gas. They are visible across the electromagnetic spectrum from radio waves to gamma rays, and they are some of the most dramatic features of the active universe. From a distance, the jets would appear as thin, luminous threads stretching across the darkness like strands of cosmic light. They are not uniform. They contain bright knots and dark gaps, evidence of turbulence and instability in the flow. They are dynamic structures, constantly changing and evolving as they travel through the universe. The jets are not just beautiful, they are also important. They carry energy from the quasar into the surrounding space, heating the intergalactic medium and affecting the evolution of galaxies. They are part of the feedback process that regulates star formation, and they play a key role in shaping the cosmic web. When we observe the jets from a quasar, we are seeing one of the most extreme manifestations of gravity and magnetic fields. We are seeing matter accelerated to nearly the speed of light, launched across the universe in a beam of pure energy. It is a reminder of the immense power that lies at the heart of galaxies, and of the intricate connections between the smallest particles and the largest structures. As we drift through this chapter, let yourself rest in the quiet. The jets are a spectacle of cosmic proportions, but they are also a natural process, a consequence of the laws of physics playing out on the grandest scales. They are not something to be feared or marveled at. They are simply part of the universe, part of the great tapestry of matter and energy that surrounds us. Let your thoughts settle like dust in still water. The universe is a place of extraordinary complexity, but it is also a place of profound peace. There is a rhythm to the cosmos, a slow, patient unfolding that has been happening for billions of years. You are part of this rhythm, part of the great dance of matter and energy, and you are safe, held in the quiet embrace of the night. Rest here, in this stillness, for as long as you like. The jets will continue their journey, and we will continue ours, but there is no rush. There is no destination. There is only the slow, gentle drift through the cosmos, and the quiet wonder of being alive to witness it. But we will not go there yet. Rest first. When we consider the fate of quasars, we are really considering the fate of galaxies themselves. A quasar is a phase, a stage in the life of a galaxy that begins when the central black hole is fed and ends when the fuel is exhausted. It is a temporary state, a burst of brilliance in the long, slow history of a galaxy. But its effects are permanent, shaping the galaxy for the rest of its existence. The quasar phase is triggered by a disturbance, usually a merger with another galaxy, or an inflow of gas from the surrounding environment. This disturbance funnels matter toward the central black hole, igniting the accretion disk and launching the quasar. The quasar burns brightly for a few million years, a brief moment in cosmic time. But during that moment, it releases an enormous amount of energy. This energy drives gas out of the galaxy, quenching star formation and transforming the galaxy from a blue, star-forming system into a red, passive one. The quasar's jets heat the surrounding gas, preventing it from cooling and forming new stars. The result is a galaxy that has been permanently changed by its quasar phase, its future evolution determined by the brief, brilliant outburst at its center. After the quasar fades, the galaxy settles into a long, quiet existence. Its stars continue to burn, gradually aging and dying. Its black hole sleeps at the center, waiting for the next disturbance. The galaxy drifts through the universe, a quiet island of stars in the vast darkness of space. It may never experience another quasar phase, or it may undergo several over its lifetime, depending on its environment and history. The Milky Way has had quasar phases in its past. Evidence suggests that our galaxy's central black hole, Sagittarius A star, has been active at various times over the past billions of years. These phases were triggered by gas inflows, perhaps from the accretion of smaller galaxies, and they left their mark on the surrounding gas and stars. Today, Sagittarius A star is quiet, a sleeping giant at the center of our galaxy. But it may awaken again in the future, when the Milky Way collides with the Andromeda galaxy in about 4 billion years. This collision will be a transformative event for both galaxies. Their stars will intermingle, their gas clouds will collide, and their central black holes will eventually merge. The result will be a new galaxy, an elliptical system with a supermassive black hole at its center. This merger may trigger a new quasar phase, a final brilliant outburst before the new galaxy settles into quiet old age. It will be a spectacular event, visible across the universe, a fitting end to the story of the Milky Way and Andromeda. But this is billions of years in the future, far beyond the span of our lives. For now, we can rest in the knowledge that our galaxy is stable, its black hole sleeping, its stars burning steadily. We are safe, drifting in the quiet embrace of the Milky Way, part of a story that began long before us and will continue long after us. As we contemplate the fate of quasars and galaxies, let yourself settle deeper into the quiet. The universe is a place of constant change, of birth and death and rebirth, of brilliance and darkness and brilliance again. It is a cycle that has been repeating for billions of years, and it will continue for billions more. You are part of this cycle, part of the great flow of matter and energy that shapes the cosmos. Rest here, in the awareness of this cycle, and let it soothe you. There is nothing you need to do. There is nothing you need to solve. Simply float and breathe, and allow yourself to be carried by the slow, patient rhythm of the universe. The quasar fades, and the galaxy sleeps, and the night stretches on, vast and quiet and full of peace. Let your thoughts loosen. You are part of something